Hello, Mr. Peterson here again with some more physical science concepts. Today we're going to be talking about motion, specifically speed, acceleration, and velocity. And as you can see on your screen right now, motion is a changing position with respect to a reference point. Well, what is a reference point? So a reference point is a stationary object that you can compare to a moving object to. So that means something that I can compare something to make sure it's moving. So if I look at this picture right here, which make it a little bit bigger so you can see. Look at this picture. I have this white line, which would be my reference point because it's a stationary object. It's on the ground, it's staying in one spot, but I can see if I compare these two pictures, I can see that the person that took these pictures has moved since the white line has moved in relation to the background, and the other reference points in the picture. Some other things that we can look at is this car. So if I wanted to see if this car was moving, and right now, it would be kind of easy to tell because I can compare it to the words. But if it was on an all-white screen or something like that, I wouldn't be able to. So a lot of times we don't have words in the background when we're watching cars, but we have a stop sign. So I can watch this car be in motion compared to the stop sign. Because when it's driving up to the stop sign, I can see the stop sign staying in one point, which would be our reference point. And I can see that the car is, in fact, moving. So our stop sign is our reference point. Our car is our motion. Now, the other thing, if you wanted some more help on motion, you can look for is in the speed note card, which we'll get to in a little bit later. The next thing, speaking of speed, is speed, which is the rate at which an object moves. So if we take our same example of watching our car and our stop sign, we can see how fast this car goes from this point to this point, or how fast this car goes from here to the stop sign. And how we're going to do that is we're going to need a couple of things. In our class, we use what's called the speed triangle. The speed triangle gives us the speed equation, which is speed equals distance over time. Speed, we use v because speed is very similar to velocity. So when you see v, sometimes our textbook and sometimes other people will use s, but we need to know that speed is distance divided by time. So if I was looking at this car, I can see here's my car and here's my distance. So let's say this is a distance of 10 meters. Let's say it took the car a time of 2 seconds to get there. So if I do that, distance is 10 meters, my time is 2 seconds, so 10 divided by 2 is 5 meters per second. Now, the label for speed is meters per second. The reason it's meters per second is if we look at the equation, distance divided by time, we have a distance, which is meters, and we have time, which is seconds. So it gives us our distance over whatever unit we're using for time. Let's look at an example problem. So while driving to New York, I realized that I had traveled 100 meters in 50 seconds. How fast was I traveling? So if you want to go through the entire 5-step process of how to figure this out, I would suggest watching the note card video, which the note card video is in Chapter 5, Section 1 videos. There's a front and a back, and I think it could be very beneficial. So I'm going to do kind of the shorthand way. So if my distance is 100 meters and my time is 50, I know that that's going to be 20. And what's my label again? You're right. Meters per second, meters per second. And once again, my last thing is I want to talk about the 20. Now, if you're at home using your calculator, you notice that, Mr. Peterson made a mistake. It is in fact not 20 meters per second, it's only 2 meters per second. So I did this on purpose to remind you to use your calculator, to make sure that you're doing these things correct. Because you don't want to miss points just because you're doing something in your brain or in your head. You might as well use your calculator. The next thing I want to talk about is velocity, which is speed with direction. So if I was looking at an airplane, I could see right here, this airplane, we would say this is going 100 kilometers per hour south. Because the arrow was pointing down, we're going to say that's south in this case. So when we talk about velocity, there's certain things that we need to look at. When velocities are moving in the same direction, so this one, here's the plane going this way, here's the wind going this way, I'm going to add those two velocities up. So I have 100 plus 25, which gives me 125 kilometers south. So now, what do you think we're going to do if velocities are moving in different directions? You're right. We're going to subtract them. So we subtract them if they're moving in opposite directions. I have a little animation that I'd like for us to look at. So if we look at this animation right here, we can see these three planes are actually going the same speed. But what happens is when we add in the velocities, this one has tailwind, which is actually helping it or reinforcing its speed. This one has headwind, which means the wind is going straight into it, which actually slows it down. This one has crosswind, which means that the wind is pushing it this way. So the velocity of these planes are different because of their resultant velocities, even though they started out going the same speed. All right. Now, lastly, The three things that can change velocity, are the three ways to change it, are you can speed up, you can slow down, or you can turn. So as we looked at in the animation, we saw the plane going faster, going slower, and then changing directions. So if I was to do this problem, while running 10 meters per second forward on a plane that is going 100 meters per second, I found the girl of my dreams. So I like to draw pictures. I think for velocities, they really help. So here's my plane. Here's the plane that I'm going on, and I'm running on it. I'm running this way, 10 meters per second, because it says I'm going forward. The plane is also going this way, which is 100 meters per second. So are those going in the same direction? Yep, so I would add them. So my resultant velocity would be 110 meters per second this way or forward, whatever direction that is. And finally, I want to say note card again. If you need some more help or you want to see some more velocity practice problems, you can go watch the note card video. Next part we're going to talk about is acceleration, which is the rate at which something changes, or the velocity changes. So this hockey puck right here, right now might have a velocity of 0 because maybe it's not moving, but once this hockey player hits it, it's going to have a velocity going this way. Once the goaltender stops it, it's going to have a velocity this way. So while its velocity is changing, it's also going to have an acceleration, because acceleration equation we can figure out by finding the final velocity and the initial velocity and the time. So if this hockey puck was starting out going 0 meters per second to the right and ended going 0 meters per second to the right, technically it would have no change in velocity. However, in the middle it would have some velocity. So we're going to look at some examples of this. The label for acceleration is meters per second squared. So the reason we're doing this is every second the hockey puck or whatever it is will accelerate, speed up, slow down, whatever it does, by a certain meters per second or a speed. Now, this is very important to remember. Whenever something is slowing down, it's going to have a negative acceleration. And negative acceleration, the negative sign says that it is in fact slowing down or stopping. As we talked about earlier, there's three ways that you can change acceleration and velocity. You can speed up, you can slow down, or you can turn or change direction. And I want to look at this practice problem. So I tackled a running back, stopping him from 37 meters per second in 2 seconds. So what I like to do is write down what's my final velocity. Well, if I tackle somebody, it's going to be 0 meters per second. What's my initial velocity? If they're starting out, they were starting out at 37 meters per second, and my time is 2 seconds. So if I plug this into my equation, I have 0 minus 37. And it's very important to make sure that you match up correctly. So final comes first, initial comes second, and divided by 2. To make sure that I'm doing this correctly, I'm going to do this first. So 0 minus 37 is going to be negative 37 divided by 2, which gives me a negative 18.5 meters per second squared. And what does the negative sign tell me? You're right, that I am slowing down. That's what the negative sign in acceleration tells me. Finally, I want to throw out the note card once again, Chapter 5, Section 1, video section, if you really want to see some more pictures and animations on how to find acceleration. So here's the last part of the video we want to talk about. How do I know what I'm looking for? Well, if I'm looking for acceleration, I'm going to be given 2 speeds or velocities and a time. So every time I see 2 speeds and velocities and time, I know I'm looking for acceleration. If I'm looking for resultant velocity, I'm going to be given 2 speeds and velocities, and that's it. Okay, I might be given a time, but we need to make sure that if it's asking for velocity, those are the 2 things that I'm using. If I'm given speed, or if I'm looking for speed, I'm given distance and time, or I'll use distance and time. If I'm looking for distance, I'll be given or use speed and time. And if I'm looking for time, I'll be given distance and speed. Finally, if you need some more help, see Chapter 5, Section 1 webpage, which I'm going to go to and show you right now for more help. It's right here. It has review games. It has websites. There's videos. The note card. It has, you can use, there are some problems, how to find acceleration. There's some speed simulation. Also, if you need some more help,